Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the first chapter in chemistry, chemical reactions and equations. In the first video, we learned about chemical reactions, chemical equations, types of equations and how to balance chemical equations. In the previous video, we learned about the types of reactions, their names, which are they: combination, decomposition, displacement, double displacement, oxidation and reduction. Of that, combination reactions we explained in the previous video. To just revise, combination reaction, what are the examples we studied? Calcium oxide combines with water to form calcium hydroxide or slaked lime. The second example was burning of carbon, that is with the oxygen to form carbon dioxide. Third, hydrogen combines with oxygen to form water. Apart from this, I gave you some other examples also. Then, since the first example that we told, calcium oxide and carbon dioxide reaction, is exothermic, we learned a few examples of exothermic reactions as well. The first one was this calcium oxide reacting with the carbon dioxide itself is an exothermic reaction. Burning of natural gas, methane, is an exothermic reaction. Respiration is an example of exothermic reaction, and decomposition of vegetable matter. Having revised that, we are going to the next type of reaction, that is called a decomposition reaction. So when you learn each reaction, first you learn what is the type, what is happening in that reaction, then learn what are the examples given in the NCERT by heart. That's it. Okay. So like that. That's why I gave you an idea how we have to repeat and recollect and see whether I know that. If you are thorough, then go to the decomposition reaction. In decomposition reaction, actually this is opposite of combination reaction. In combination reaction, what did we see? Two or more substances are combining to form a single product. So LHS we have two or more than two connected by plus, whereas RHS we have only one product. So such reactions are called a combination. Here it is opposite. Then what will come? A single reactant. So left hand side we have only one reactant, but it will decompose to form many products, means it can be two or three, we connect it by plus sign. So that is why we are calling opposite. So here LHS only single, right hand side it is multiple. Understood? So in decomposition reaction, usually most of the decomposition reaction can happen only in the presence of energy. That means we have to provide energy from outside for the decomposition to happen. What do you call such reactions? Endothermic reactions. So, endothermic means energy is absorbed for the function or the process of the reaction. So, we can give this energy in different forms. Depending on that, different types of decomposition reactions are also there. The first one is called a thermal decomposition. Therma means what? Heat. So simply if you are heating the compound to break it into or decompose into its products, then we call it as thermal decomposition. So here simply heating is needed. Okay, second type is called a electrolytic. From that word itself we are getting an idea, we have to pass electricity so that we can split that compound. Third is photolytic. Photo means what? Light. Lysis means breakdown. So if you are passing light or if you are exposing it to light, if it splits into products, then we call it as photolytic decomposition. Okay, so once again, the reaction in which a single substance split into two or more simple substances under suitable conditions is called the what? Decomposition reaction. In most of the decomposition reaction, we have to give energy in a particular form. That is why it is called an endothermic reaction. Depending on what type of energy we are providing for the reaction to happen, three types of reactions or decomposition reactions are there: thermal decomposition, electrolytic decomposition and photolytic decomposition. Now we will learn the example of each one, then you will be thorough with this type of reaction. Now we will see the examples of thermal decomposition. So as per the NCERT, we have to learn three examples: the decomposition of a ferrous sulfate, decomposition of calcium carbonate and decomposition of lead nitrate. Now itself by heart, ferrous sulfate, calcium carbonate and lead nitrate are examples of thermal decomposition. Now if you have this tagline, then you can develop the equation, right? So here we are taking 2 to 3 grams of ferrous sulfate. Why is it called ferrous? Because its valency is 2. That all we learned in the video which I mentioned about all the basic things you should know about chemistry. If you haven't watched that, please watch that. I will give the link in the description box. First you learn that, only then start with this. So iron's ferrous sulfate is taken in a test tube. What is the color of this ferrous sulfate? It is a white powder. Okay, it is white in color. We have to take it in a dry boiling tube. You know the difference between test tube and boiling tube. Boiling tube, it is little bit larger and it can withstand heat. So you just take the powder, white powder, heat it. Then you can see that the color is changing, because what will form from ferrous sulfate? Ferric oxide will form. What is ferric oxide? Ferric means valency of iron is 3. So Fe2O3. So this is ferric oxide, which is yellowish in color, and along with that sulfur dioxide and sulfur trioxide will form. So here it is solid, here it is gas, here also gas. Okay, so this is yellow color. Along with that sulfur will be liberated, sulfur dioxide and sulfur trioxide. So you will get a pungent smell of sulfur. So here two observations, one is color change, yellow color, and pungent smell of sulfur also can be experienced in this case. When we learn combination reaction, we learn calcium oxide combines with water to form calcium hydroxide. When this calcium hydroxide was used for whitewashing, it combined with carbon dioxide to form calcium carbonate. But in nature, we get calcium carbonate in different forms, like in the form of marble, limestone, chalk, etc. So for many commercial purposes, we need calcium carbonate. So we have to break this calcium carbonate that we obtain into calcium oxide, because we need calcium oxide for various purposes. One main important industry depending on that is cement manufacturing. So for breaking down this calcium carbonate, that is limestone, we have to again heat it. So here also, here I am giving a triangle. This shows heat is given. So since it is endothermic reaction and we are heating it, you have to write heat on the arrow mark. So calcium carbonate, when we are heating, what will we get? Calcium oxide. Okay, that is called a quicklime. Quicklime we get as a solid, plus what will we get? What is Ca? CaCO3 we have. Of this CaO is gone. Then what is left? CO2. That is gas. So here it is a balanced equation. Fe, Fe2. So we have to write here 2Fe SO4. Then now SO4 becomes 2. Here SO4 is not coming as SO4 on the other side. So we have to check individually. Yes, how many are there? 2 are there. Here 1 and 2 are there. Then oxygen 4 into 2, 8. Here 3 plus 2, 5 plus 3, 8. So by adding 2 here, the equation is balanced. Whereas this is balanced equation, Ca, C, CO3. Okay, so balanced. Then next is we are taking another boiling tube. Again in that we are taking some lead nitrate in it. Lead nitrate is again white in color. Okay, this white color lead nitrate we are heating. So what will you get? Lead oxide you will get. Lead oxide. Lead oxide is yellow in color. Okay. Now along with that, what will you get? From this lead and O gone, right? Now we have NO2 left, nitrogen dioxide, plus still oxygen is left. So oxygen also will be liberated out. So these two are gases. Okay. So when lead nitrate is heated, what do you get? Lead oxide, that is white lead nitrate, change into yellow lead oxide, plus nitrogen dioxide. Nitrogen dioxide is a brown fumes. And oxygen also will be liberated. Now we have to balance this equation. Here one lead, here also one lead. Okay. Now we will see nitrogen. Nitrogen 2 times here, here only 1 time. So we will make 2 here. So now again we have to check lead. Lead 1, nitrogen 2, here also 2. Now only oxygen we have to balance. Oxygen is 3 into 2, 6 here. Here 2 into 2, 4, plus 2, 6, plus 1 is here. Right? So we cannot make, this is odd number. So we will put 2 here. Here 2 into 2, 4 it became, but here only 2, so we will make it 4. Okay, so now let's see, lead 2, lead 2, okay, fine. Nitrogen 2 into 2, 4, here 4, fine. Oxygen 3 into 2, 6, 6 into 2, 12, here 2, 4 into 2, 8 plus 2, 10, 10 plus 2, 12. Now our equation is balanced. Okay, so these are the examples of thermal decomposition where we heat for the decomposition reaction to happen. First, ferrous sulfate will decompose to form ferric oxide and sulfur dioxide and sulfur trioxide. Second, calcium carbonate or limestone will give quicklite, which is used in cement manufacturing, and carbon dioxide gas is evolved. Then lead nitrate on heating will become yellow color lead oxide, and a brown color, reddish brown color fume will come out, that is nitrogen dioxide, and oxygen gas is also formed. Next type of decomposition is electrolytic decomposition. In electrolytic decomposition, we are using electricity to decompose a compound. Here we are going to decompose water. For this there is an activity. Take a plastic mug, drill 2 holes at the base of it. Then we can close those holes with the help of rubber stoppers. Now we have to insert 2 electrodes, carbon electrodes into it, and connect those electrodes to a 6-volt battery. Now we have to fill water covering the level of the electrodes. After that, bring 2 test tubes filled with the water and invert them on the electrodes, and then switch on the current so that electricity will pass through it. But before that, the water simply cannot pass electricity. We have to add a few drops of sulfuric acid in order to make it pass electricity. Now, if you keep it undisturbed for some time, you can see that some bubbles are forming in each test tube over the electrodes. As the bubbles are forming, it will displace the water down. So, after collecting it, you can see that in one test tube, the amount of gas collected is double than that of the other test tube. Now take out the test tubes. This gas can be tested one by one. So we know water when split, obviously we are going to get hydrogen and oxygen. So how will you test for the presence of hydrogen? You have to bring a flame near it. If it is burning with a squeaky pop sound, then it is called a hydrogen. So we can test like that. In the other test tube, if you are bringing a flame inside it, and if it is burning or reigniting the gas, then it is the oxygen gas, because oxygen supports combustion. So this way we are finding that water is split into hydrogen and oxygen in the presence of electricity. Here we saw that hydrogen was going up, displacing water down. This is what I mentioned earlier, that is downward displacement of water is happening when we are collecting hydrogen. So here double hydrogen is formed than oxygen, because we observed in one of the test tubes the amount of gas collected was double than that of the other one. Which one was more? Hydrogen was double than that of oxygen. Why? Because in the formula of water, we know water is a compound. Compound means the elements are combining in a definite proportion by mass. So here H2O, 2 parts of hydrogen to 1 part of oxygen. That's why hydrogen is double. Last type of decomposition reaction is photolytic decomposition. So here we are taking a white color silver chloride. Silver chloride we can take in a china dish. It is white in color. This is white in color, solid powder. And you leave it in the sunlight open for some time. Then you can see that this white color silver chloride is gradually turning into grey color. Why? Because it is becoming silver by decomposition and chlorine is released out. Okay, so white silver chloride turns into grey color silver on exposure to sunlight. So since here we are giving energy in the form of light, we call it as photolytic decomposition. Then second is a similar experiment, silver bromide. If you keep it outside in sunlight, what will you get? Silver and bromine will be liberated out. Now let us see, these are balanced equations. Here Ag, but Cl2, so here we have to make it 2AgCl. Then Ag is changing, so here I am making 2Ag. So 2AgCl gives 2Ag plus Cl2. The same way 2AgBr is equal to 2Ag plus Br2. So these are examples of a photolytic decomposition. One more question you can get, what is the application of this? This is used in black and white photography. Hope all these concepts are clear for you. decomposition and types of decomposition. So whenever you mention in the answer sheet word the decomposition reaction or you identify it as a decomposition reaction, try to write what type of decomposition is it. Is it thermal, electrolytic or a photolytic also. If you understand all my lessons, please like, share and subscribe to my channel Biology My Passion. Thank you for watching.